These researchers are deep inside the Arctic Circle.
You have to put the gloves on again.
Scrambling to solve one of the biggest challenges mankind has ever faced: the decline of sea ice. From underwater drones to tiny glass beads designed to reflect sunlight away from the ice, the race is on to slow the melt and in turn global warming. In a desperate bid, researchers are increasingly turning to geoengineering innovations. The Wall Street Journal exclusively followed one team with a big plan to future-proof the region.
Of course, it's challenging to work in, but it's great for freezing.
By making more ice. This is Svalbard, one of the coldest inhabited places in the world. The Norwegian archipelago is inside the Arctic, where sea ice covers roughly 6.2 million square miles in late winter. In summer, as the weather warms, it melts to its lowest level, but that ice has been shrinking at a rate of around 13% per decade, which could have catastrophic consequences for the world.
In essence, it helps keep the planet cooler than it otherwise would be. So if we start melting away the snow and the ice, we're going to warm up faster.
Sea ice reflects sunlight back into space, which means as it melts, the Earth absorbs more heat. One study estimated that the complete disappearance of Arctic sea ice in summer would have the same warming impact as 1 trillion tons of carbon dioxide. That's more than double America's historic emissions. A Dutch startup is attempting to slow the melt by geoengineering the Arctic.
Why am I doing this? Well, I was first intrigued by the question, will it work? It's partly because I thought if I can do something in our battle to curb the climate change, then I should just do it and I should just go. I told my daughter I'm going out to try and create new ice so we can potentially save the polar bears.
Ice fishing.
So the Dutch way of trying to build ice rinks for ice skating marathons was really an inspiration for us for the ice thickening project.
This is the team's first field test at this site in the south of Svalbard. The startup has enlisted scientists from 2 universities to experiment with ice thickening methods used by the Dutch ice masters.
What they do, the ice meesters, as they call it, of these villages, they put thin layers of water on top of the ice to make it freeze faster. If we thicken enough of the ice, we can maybe stop the decline so long that we can bring down the CO2 emissions and the ice becomes regenerative by itself again.
Similar methods are widely used in Canada, where pumped water is frozen to create ice roads strong enough to carry the weight of trucks.
That's been done for decades already, and that really helps. There's a lot of engineering knowledge about that.
To see whether those methods could work to save the ice here in the Arctic, the team first needs to understand the environment they're in. To do this, they're drilling and taking samples, which allows the team to look inside the core of the ice.
So it's quite a thick piece of ice already, but it has been very cold here the last month.
This ice core currently measures around 36 inches. The team estimates they could add up to 14 more inches of thickness.
If we are really successful, that would be in the order of the 1/3 of the core.
They're taking out hundreds of ice cores across the testing area.
So we take 2 of those in every site where we probe. And the purpose is to obtain the salinity of the ice, temperature and the density.
The salinity, or simply how salty the ice is a vital question for the team to understand. Because when saltwater freezes, it creates small crystals that form into bigger ice chunks over time. During this process, gravity expels the salt back into the water below it. The researchers need to understand how putting salty water on top will interact with this natural process.
But of course now we put it on top of a layer of snow and intact ice, so we don't know if there's sufficient time and sufficient drainage down, or if it stays in some kind of small, highly salty layer, which will maybe not even freeze, because the salt water has a much lower freezing point.
Understanding temperature variations within the ice is essential to knowing how well the experiment will work.
So we drill a hole into the core, as that is what the actual ice temperature is. I'm already at minus 4.5 right now, which is almost halfway in the ice core. So outside temperatures are right now much colder, around minus 17, minus 18. So that's why you see that the top part is much colder than the bottom part over here. Because we're actually putting relatively warm water on top compared to what's maybe the temperature inside the core. So we want to see how this flooding is actually changing the temperature profile.
At the heart of the experiment is technology to get the water onto the ice in the first place. By connecting these pumps underneath the ice, water is resurfaced to freeze again. The group is pumping over 900 gallons of water per minute for hours at a time. In total, they're covering an area roughly the size of 2 football fields with water. But how to power the pumps is a challenge.
Well, it's kind of ironic to use diesel to try to thicken the ice when we know that fossil fuel emissions are one of the reasons that we're thinning the ice and losing the ice.
If the project is successful, the startup aims to use renewable energy to power the pumps in the future.
So that's one of the scaling challenges that we have, how to bring the renewable energy here, or maybe use local wind power, and how to do that in conditions of -40.
Other researchers are piloting more environmentally friendly technology to resurface seawater. Drones that can travel under the ice and pump water on top are in development. The company behind them aims to power them using green hydrogen. Other experiments include spreading a fine layer of reflective glass microbeads across the ice surface in a bid to bounce more sunlight back into the atmosphere. During one test, the method slowed the rate of melting by around 30%, according to a peer-reviewed paper. But all of these innovations will require large sums of investment and international cooperation. One estimate put the cost of scaling up similar projects at $500 billion. By comparison, one study estimated that the acceleration of climate change, driven by a thawing Arctic, could cause up to $130 trillion of extra economic losses over the next 3 centuries. However, critics warn about the unintended consequences of this well-intentioned tech.
If you try to regionally cool the Arctic, for example, but still warming up the rest of the planet, that temperature difference between the pole and the equators, which drives a lot of our weather systems, that's going to have, knock-on consequences on our weather patterns. For me, the geoengineering solution would be to do more carbon capture, to come up with better ways to take the carbon out of the atmosphere.
The researchers here are hoping their Arctic tests will be the first step in proving the case for this technology. Final results to see whether they slowed the rate of the melt will come later this summer. If successful, they will try to prove that ice thickening can be done at a much larger scale.
Our engineering companies have seen greater challenges than this.
But even if this experiment is successful, on its own, it's not enough. Its power to combat declining sea ice will ultimately hinge on the success of other efforts to cut emissions worldwide.